All right, hello everyone, and welcome to our performance and optimization stream. All right, so I'm Tobbs, aka Tasha, and today I am joined by three amazing manticores. So we have Ryan, aka Big Ol' Buns, our lead gameplay designer. You may know some of his work. He worked on Hop Till I Make You Drop, Farmer's Market, Boss Fight, basically
everything, basically.
Yes, exactly. We have Gabe, aka Standard Combo, our lead gameplay engineer, and if you guys have used the NPC AI kit or Cinematic Shot or any of his other amazing community contents, you're already familiar with his work. Oh no, and then I have...
Hey everybody.
That's not...
Hey!
I have your webcam switched around. That's not Ryan.
Wait a minute, Gabe, what are you doing up there? What are you doing up there, Gabe? You're not Ryan.
Man. Okay. And then anyways, we also have Curtis, someone you may recognize from Core Live. This is Curtis. He will yell at you to make your game better. You may know him from Play with the Devs, and his official title at Manticore, or his alleged title at Manticore, is Big Papa. So, do with that what
I'll go with
you
that.
will.
I like that. Big Papa.
All right, and then I'm going to throw the stream to you guys and maybe do some fixing of the webcams here. All right, Ryan, do you want to start off?
Yeah, all right. So I want to go over a lot of different performance-related tools and techniques that you can use. There's quite a lot of ground to cover, so I'm going to try to go through with some really, really specific examples and show as much as possible and talk about some of the sort of high-level theory around why you would approach it in a particular way. So I'm just going to go through some of the different tools in the editor that you'd want to be using. And this is basically an empty scene except this giganto ground plane that I made. So there's a few different things that you will want to use for evaluating how well your game is running. The first one to note is this checkbox here under Game Settings, Enable Play Mode Profiler. This will not do anything when you're in preview mode like this, but when you hop out, you run a local server, which I'll show in just a second, you're going to get a bunch of information as your game is running. So you can test, you can see really detailed statistics that are very helpful for making your game run as smoothly as possible. There's also this performance panel here, which is kind of a quick view with some really helpful information and graphs, and it also breaks down by spec level, so you can see for low, medium, high, and ultra settings, and low, mid, and high end spec. So you can get a sense for how you're sort of serving different level machines, and if your game is going to maybe run okay on like medium or high-end specs, but it's not really going to work on low end spec. So those are, and there's one more that I'm going to show a little bit later that's fairly new. It is the CPU profiler, but I'm going to save that.
I was actually going to suggest Gabe start mouthing to your talk so he could be like...
Yeah. So the first thing I'm going to do is I just want to show the profiler because there's a lot to go over there, and I think it really helps to give a good high-level overview of how to be thinking about performance optimization generally. So I'm going to bring this guy up here. There's a ton of information here, so I just want to pause for a second to kind of talk through the different pieces and talk about what the strategy is when you're looking at a game. Obviously, this one is a kind of baseline, totally empty, and you're just going to be adding more and more stuff to it. So the way you want to think about this is you have a few different, like I call them shoeboxes, that you can put stuff into in your game, and you have different components or pieces of content that go into those different boxes. They're mostly the game thread time and the render thread time are the CPU, and then the GPU is like your graphics card, which is actually doing the action of drawing everything on your screen. These are then funneled to your frame time, which is measured in milliseconds, and that's going to tell you how fast your game is running overall. So these are like accurate numbers that are going to give you a sense of if your game is going to be expected to run at 15, 30, or 60 frames per second. You really always want to shoot for a game that runs at 60 frames per second if it's at all possible. this is sort of one of the important life lessons in game design that you'll pick up. Is game performance is one of the most critical factors to improving a game's retention and overall playability. You can just think about it like if half the people have a really laggy or game experience or one that doesn't run smoothly, they're just not going to play. They're going to quit out. So really, this is one of the most important things that you can focus on if you are in the state where your game does not seem to be running well. You've maybe added too much. How do you kind of pull things out and pare it down? So the way you look at this is your frame time, basically 1,000 divided by your milliseconds, is going to give you an estimated frame rate. So if you're at 16.3, I think, milliseconds, that is equivalent to 60 frames per second. That's kind of where you want to be. If you're higher than that, you can get up into probably 30 milliseconds, depending on your machine quality, and you might be, you'll be at 30 frames per second. So somewhere in that range, between 16 and 30 milliseconds is going to work. When you start going above that, you're going to see really substantial slowdowns, or like you're playing in molasses. It's going to be really problematic. So the way you look at this is when you're evaluating how to make your game run better. Again, this one's totally empty, but you look at whichever of these is the biggest. So game thread time, render thread time, and GPU time. And it's like whack-a-mole. You want to focus on the biggest one and bring that down, because everything is synced up in the frame to match. These are 3 different processes that are running in parallel. So you want to look at whatever the biggest one is and then reduce that. It's not really going to help me in this case to reduce the render thread time, because I'm bottlenecked right now by the game thread time. Mostly, it's actually more the graphics card, but these are really low settings. So anyway, so that's how you look at that, and then you've got this nice clickable frame section that lets you look at what's happening specifically in each frame. You can see there's a lot of variance.
And what do we use frame time for, Ryan? The one on the left?
That's just the total, or like.
Yeah, that's how long it took to render that frame. And I believe it. Okay, yeah. So this one was 19.1 milliseconds for that specific frame. And then here you can see this is the highest one recently. So there are improvements that are going to be made to this in the future to make more sort of clear capturing of like averages over a period of time, but you can kind of get a sense for it by kind of clicking through. Yeah, so you can click on the different frames. You also have a breakdown of what's happening in the game thread and the render thread. So the game thread is going to have all of your like game logical pieces. It's going to have your animations, your scripts, your UI, any updates that you're running to different objects or UI pieces in the world, anything with cameras, physics, sometimes particle simulation with physics. Those are all going to kind of be captured here. So this is like the game processing stuff. The render thread is basically the sort of, it's still on the CPU. It's the process that sets up your graphics card to actually draw everything on the scene. And render thread is mostly going to be related to the number of objects that you have in the scene, and to some degree the complexity of the objects that you have in the scene. There are some features coming soon that we'll go into that are going to throw that on its head a little bit, but generally, when you want your render thread time to be lower, you want to have fewer objects with fewer unique materials and overall reduce that. So that's the render thread. You can also see some details on how many triangles drawn. I'm going to go to that in a second. And this is just sort of to give a baseline. But that's the profiler, and so you can run it live, and you can jump around, watch things change. So cool, empty scene, pretty boring so far.
Yeah,
so
you're gonna show us some objects?
No, that's the whole thing. That's all I got. Cool, so I actually just wanted to go through and show some things I was doing today for optimization, just because I thought it'd be interesting. Okay, so here's a really simple case. So this is one of the lanterns from Core Haven, and this is used in High Rock as well. I think it's not this double one, but it's a similar one. And so I want to put this into the scene, and then I'm going to hop out again and just look at the profiler with that object in the scene. I scaled it up a little bit. So there's a few things that you can notice here. You're not going to really see a big difference in the game thread or render thread time with just like one object, but you do see here static mesh triangles drawn. This was like 7,800 before. It's now 86,000. So it's actually, and that's pretty high for a single object. So that's something to note. I'm going to go into that. But yeah, you can see mostly the number of core objects, 119, so we added, I think it's like 110. Yeah, and this, so I'm gonna hop out now, and this particular case is important to note because it is an environmental prop that you're gonna replicate a ton of times in your level. You're gonna be copying this and you're gonna be putting it everywhere because it's just like this lantern, right? And it's really, really beautiful. It's like very detailed. But there's something about it that is important to note, which is that these ropes here are all, I believe it's a ring thick mesh. So these are going to be really heavy on the triangle count. And they look great, but you probably don't need quite as many of these here. So I made another version that's a little bit more optimized. And so I took this one and I was like, all right, well, I don't really want it to look noticeably different at all, but what if I just delete a bunch of those ropes? So try that. So yeah, this is pretty simple, but.
So we had a question from Luck a Buck. So for render, using the same amount of objects with the same material versus each object using a different material would jump that render time up? Question mark. Depends on the material.
Yeah, it depends a little bit on the material, but generally object count and number of materials used are going to be driving the render thread time substantially. So if you can reduce the number of unique materials that you're using, that's going to help on the rendering and the GPU. Oftentimes these are really subtle differences, and the one thing I would say is like you don't need to go bananas as you're making stuff unless you actually have a problem. So often you're going to find that your game thread time, like something in your scripts or your game logic, is what's actually making your game run slower. That's where your bottleneck is. So optimizing the environment art is not going to help you really at all, but you do want to have kind of good practices, because if you then go in and optimize the game thread, you're going to have a lot of work to do on the render thread. So just starting with like a good foundation is helpful. So hopefully that answers the question.
And it all adds up. Every little bad thing you do. Yeah.
Thomas Miles asks if smart materials have any innate render cost difference to non-smart, and I don't think so.
I think they're the same, yeah.
Yeah, it should be about the same.
Yep. Yeah.
Because that's just the UV mapping. UV mapping doesn't have any extra cost.
Yep. Cool. So in this case, you can see the static mesh triangles drawing went down to 49,000 just by deleting a bunch of those ropes. And basically, like, I don't think any player is going to come in and be like, oh, there's not enough ropes on this lamp. Like, screw this game, right? Like it's it's pretty similar looking. So this is like a design choice that you can make that typically you would want to make after you've built the art out to look as good as possible, and then you can say, okay, well, what are the expensive pieces, and how can I pare this down to be smaller? So let me hop out really quick. So I've got this one here. And then I did another one, and so in this one, I just did a little bit more optimization. I think I got rid of a few more of the ropes. I took a look at the lantern here. It had some extra pieces of rings. So that
can't really tell the difference.
Yeah, I still can't really tell the difference. And then I did a third one. And this one just did a few tricks So instead of having these rings, which I know are high triangle count, I just used a frame material to wrap it around. This is one that I remember, Tasha, you did this on your very first day to make the flowers. And I was like, oh, I never thought about putting that on a sphere.
Yeah. Aw.
Yeah. So
Go Tasha.
yeah. So these again look pretty similar. Really aren't going to see too much of a difference. I think I got rid of like the ropes at the bottom. So then let's just like just look at that really quick. Again, very simple example. Let's take a look. 32,000. So brought it down from 89,000 to 32,000 just by kind of carefully plucking out some pieces that maybe weren't critical to the design. You still have the basic shape. So that's one thing that you can do. It's really important when you're doing that to test it in like an empty scene, so you can actually see the before and after differences and understand that you're successfully optimizing it. So that is.
Metal Gentalk says my problem is right now my network object count being so high that triggered events are failing to replicate.
Yeah, you're
Yes.
gonna have to fix that. That's a big issue. You're gonna. One of the main things you're gonna see is when players try to join your game after you publish it, and you try to join it, you'll see a big cost in the loading time. Sort of the time it takes for a player to enter the game goes up the more networked objects you have in the scene.
Yep.
Want to keep that number low.
Yeah, and you can see those two problems are going to manifest differently when you're actually joining the game. Like if you join the game and it feels really sluggish to move around the camera, that's usually you're having like GPU issues. But if you're having rubber banding, weird like long load times, or things like aren't loading in and then suddenly they happen quickly, or you get teleported back suddenly.
Or some objects just don't appear at all. That's an
Right.
issue as well. If you do a big chain of networked objects, suddenly one of the links in the chain might be missing.
Yeah. So yeah, they manifest differently. So the next one that I want to show is similar, but I want to show the CPU profiling. So this was another optimization. Excuse me. From Corehaven. So originally, I think some people know this already, but this is this rotating windmill, and it's basically used. There's one in the town, but it's basically just decoration, right? Like it's something in the distance that looks pretty, and it's nice to have windmills in your scene. So if I turn on this counter here, I'm actually going to see how much CPU cost is getting taken up by different objects. So when I hit play, so I turn it on. Hit play, and then now I can see. Let me go to.
You are very expensive, it seems, Brian.
Yeah. Okay, there. I got my thing. So you can actually see here, this center cog rotation is 0.45 milliseconds. So that's pretty high. You don't get. Remember, you get 16 of those milliseconds. So you're spending 0.4 of that 16 to just spin the windmill blades, which is crazy. So in this particular case, what's happening here is this client context folder has collision turned on. So this is something that actually, when you make a client context, this is why it defaults now to forced off. But it didn't used to do that. So if you force it off, and then all of these rotating pieces here, like all this stuff, turn that off, and then we run. Oops. Hang on. So look at that, and it's down to 0.21. So cut that CPU cost in half. So you're still spending a lot.
That's much better.
Significantly better, right? Like that was basically no cost at all to your game experience. There's another trick too in here that you can do. You want these hierarchies to be flat. I believe this will have a small difference, right? So if I just go in, now when I'm making it, I'm obviously going to want to group it to get the
You
different
can
models.
rotate it and whatnot, yeah.
Yep, but once I've finished with the object, you get to go in and do this sort of second pass of optimizing it. A little bit of an improvement. So now it's down to 0.12. So it's 0.14. So it's even less expensive now. That was like almost another 40% off the top, which is pretty nice.
That's crazy.
Just getting this down, because this is just about the feel of your environment, right? So you want to cut that down as much as possible. Taking this another level further,
we have one
you could
question
then
real quick.
say, hey, I want to do that windmill itself. If you look at it up close, so it's really nice. This is a windmill that, like, if I were playing around in the game and running up to it, I'd want to see all this detail, like individual beams, these nice sort of curved crescent pieces, like these beams in between. But it's a lot of objects, and for something super far away in Core Haven, you probably don't need to see this at this level of detail, right? So what I did was I was, all right, let me try making a simplified version.
Hey Brian, real quick, we've got a question about
Sure.
polished cubes and cylinders. Vargle Bargle
Yep.
ask, are the things higher poly count or just the difference in shading?
I believe the polished ones are slightly higher poly count, but we can test that really quick. So let's just do that. So we've got simple cube.
Yeah, whenever you have a question like that, run your own test as well. Just if you have a new question, right, and we're not here online to answer it, like here's how you test it.
Yeah. So I just throw it in. I'm gonna hit play. So 7,960. And then cube polished. Alright. About, and I actually don't know what the result's going to be, but this is how you would test something like that. And it's the same. Yeah, and then if I did something like
Yeah, so it's probably just a normal map in that one. And this goes to Vaj's Sizes question, was asking about 200 plus small client context triggers on their map that might be slowing down a lot. So this is how you would test it. You run this tool and check the perf. Try not to move the camera around, so you get a consistent, more scientific approach. And then you remove the triggers and test it again, or exaggerate the amount. Put 2,000 instead of 200, right? And run it again and see what the difference is in your game, because it's gonna vary from game to game as well. It depends what kind of scripts are in there and things like that.
This is a little bit higher.
And yeah, you can see like this. Excuse me. The triangle count went up quite a bit. You can also see, like, if I'm actually not facing the object, obviously it's not going to count for drawing those triangles. So you can see, like, just by moving the camera, it goes down by that amount. So the chamfered cube is obviously going to be much more expensive than just the regular cube. So if you really wanted to use that because you wanted maybe like a tiled floor look out of primitives, then you could use it. But it's just something that you want to be mindful of when you're actually picking your objects. Like, it's good to have a sense. I don't know what the triangle counts are for all these objects, but just being a little bit like mindful of it when you're making things, and just the object count in total. So
Uncle had a nice point that the wireframe material shows you the triangle stuff is made of, and she was testing a bunch of shapes to see if she could find one that was a decent spider web.
Yeah. Yeah, the spider web with the frame material and like a really high emissive. That's definitely done that. So one thing that I wanted to show was the difference. So this is the version, the non-optimized version of the windmill. And so I want to put those into the scene, and then I'm going to hop out really quickly.
The Green New Deal right there.
All right. So now with 20 of these windmills, so now we have a bigger scene. You can see that these values like shot up crazily high, right? I'm at 38-second highest frame time. This was 27 seconds. It seems like about where they're landing, just from all these windmills with collision on. So it's kind of like, all right, well, there's my game. We're done. But if you do the optimizations instead of having those non-optimized versions, we'll do that, and then we'll do the collision simplified. There we go. So these new and improved 20 windmills. Hit play, and you can see these numbers now look quite a bit better.
Wow, almost in half.
Yeah. So just by designing these, there's a lot of these windmills, there's a lot of rotating objects. These could be optimized even further from what they are, but this is definitely a step in the right direction. So all these little things add up; they count for a lot, and it's really important to get your level designed to be the sort of minimal cost as possible, and not having too much like very, very highly detailed, expensive objects in there. Cool. So Gabe, you wanted to talk a little bit about some of the performance panel networked object accounts, because this is the stuff that I just went over is important, but I want to stress that the much more common performance bottleneck that you'll run into is related to networked objects and not just stuff on the client and drawing it on the screen. So
yeah, that was related to a question from earlier. So there was actually a pretty interesting example that I wanted to ask you to go through. So if you bring in the bullet from the basic rifle in core content,
all right.
If you just bring in the basic rifle, if you bring that in, then it'll add to your project content the bullet.
Okay.
And then you can search for that.
Generic bullet.
Yeah, so the bullet actually that comes in core content has two non-recommended things. This object is pretty old in terms of core, but there are some better practices now. So this is an example of two things that you shouldn't do. First, if you click on the root of the bullet, there is no lifespan. Now, the reason you don't need a lifespan for the bullet is because the weapon itself handles destroying the bullet when it hits something or when it doesn't hit. So the weapon takes care of that. But if you're spawning things with script, with like world spawn asset, you're spawning visual effects or sound effects, you should definitely set a lifespan on those, and that's a common mistake people make. They forget to put lifespan on their temporary templates. That's number one. The second thing that you'll see in this very simple hierarchy, it's just three objects, is that the root is a group, and then there's a client context right under that. And the client context is already a group. So you have a group and a group you have an extra group for no reason. You have an extra networked object. You can see in parentheses, it says networked. So whenever you have an object in your hierarchy that has like parentheses and network written in it, right there in the names, that's an extra networked object. So if you have a game that has like a big firefight with bullets flying everywhere, that's double the number of networked objects that you actually need for the exact same game, right? So you can just eliminate that top level group and just have client context, and right under it the visual effects and sound effects. Let me maximize here and see what you're doing.
He fixed it.
You fixed it? Yeah, so exactly. That process that Ryan just did is he eliminated the top level while preserving the client context and the visual piece of the bullet. And this is now exactly the same weapon, but it's just one object cheaper per shot.
Tasha, are you there? So
Not
now,
sleeping.
because, now you know that when I come after you, I'm going to be using half the amount of networked objects.
Ooh, Curtis. At least
Be able to shoot twice as many bullets, right?
being
Yeah, right.
Yeah.
responsible.
Chaka taco. Oh, okay, so Middle Gun Talk has a couple other questions. Gabe, you wanna take a shot at those?
Well, let me wrap up the networked object thing real quick. So, when it comes to level design, people will also, in their environment, building pieces, ground, rocks, foliage, whatever, you're bringing objects out from core content, and you might accidentally set them to be networked for some reason, or putting them in a client context. And you should really put them in the default context. So what I wanted to ask Ryan to do is show that step of having an environment piece or going into the windmill and showing the difference between the default context and the network context or client context, which are distinctions that aren't intuitive necessarily. You kind of have to learn that difference. So you can see, this client context isn't even networked. So that's better. Like the least amount of objects you have in your hierarchy that have networked in parentheses next to them, the better. And can you show the filter? How can people filter by networked objects? So yeah, if you click here and you click on that networked, it's going to show everything that's in the hierarchy that's networked. And in this case, it's only the rifle, so this is perfect. And yeah, you have the client context filter as well. So this using the filter is a tip and trick that a lot of people don't know to quickly find what you're looking for, or help you optimize your game. If you have a very big map with a lot of stuff, searching object by object manually can be impossible, right? So the filters are there to help. Hopefully that will help some people speed up their games. What was the question, Curtis?
Metal Gun Talk. Got 2.
All right. Now, is it okay to have lots of highly detailed objects if they are not within line of sight due to calling? Sort of. There's always a cost to every object in the hierarchy, even if it's not within in the view. There's always a cost. So a certain level of detail just isn't called for. You go too detailed, you're just wasting resources. You want to, find a compromise. You always have to do some compromise where you have a vision for your game design. You're able to achieve that while working within the constraints of people's computers,
Yep. And one thing to add too is when you have, if you had like 50,000 objects in your level, it's going to take a long time to do even basic operations in the editor or save or autosave. And then for players loading into your game, it's also going to take a long time because they're going to have to load all those objects. So yes, you won't be paying a render thread cost if they're not visible, but you are going to be paying on the load time for the players, no matter what. So there's definitely a cost to it, but you can kind of balance that by using sort of line of sight and not having open areas that show a huge amount of objects at once. I think I can.
The second question
design,
was
right?
The second question was, would it be better to spawn an effect with the lifespan or to use the same effect and move it around, use play and stop?
Yeah, I can answer that partially. Maybe Ryan has an opinion as well, but that depends on the feature because what you're going to find is the complexity of controlling. For example, let's think about a sound and a sound that's on a weapon. The shot, each time it shoots, you want to play the pop, right? And you could put a sound effect on the client context and have a client context script that calls play on that sound each time the ability execute happens. And that'll work fine. And it's more optimal to do that than to spawn a template. Same for the visual effect. But it's a much more complicated architecture. So, and not every time it's more optimal. It depends. on the situation. So usually when you're trying to make a game, you're trying to make it in a short amount of time. You're trying to be productive about creating the game, and worrying about a detail like that in the beginning can slow you down unnecessarily. But if you have already a game and you're trying to optimize, then you can experiment with that, and you have to go, case by case and measure the trade-off. If it's a very common action that's happening constantly all the time, especially if it's only cosmetic, then doing it in a client context with a client context script is probably better. But if you have to fire, if the server script is making the decisions of when that happens, it has to fire events to the clients, and then the clients call play on the sound, then you're not really saving anything, because you're creating you're creating an expensive expensive use of your events, right? Does that make sense? So if you have to fire an event to then on the client play the effect, it's the same as spawning template. I mean, it's not the same, but it's similar.
Hey, General Crazy.
Yep. I also
want
wanted
to use the new tool.
Sorry.
I'd say use the new tool. This is awesome.
Yeah. So this is actually a new feature that
I haven't
show
used
off.
it yet.
But this is really great. So I know I ran into this, but this is a way to run like lower quality versions with multiple players. And there's a few other settings for the resolution, what monitor it goes to, throttle. So this lets you do better multiplayer testing. And I actually think it also is a good example for one of the important things to consider when you're thinking about number of networked objects. So hopefully this works capturing my screen. And these will be low fidelity graphical modes. Just loading up.
And then auto tiled, and if there's a setting there that it'll be lower performance if you're not focused on it, which is awesome.
Yep. So you can throttle. So yeah, definitely it was easy to run into really tough pressure on your graphics card if you were trying to test with 4 clients. An important thing that this is going to show is you can see when another player joins, your number of networked objects is going to scale with the number of players that are actually in your level. So you can't just look at number of networked objects when you're running around in single player mode. You have to think about it in the context of all the other people that are going to be playing your game. So
Lane Chen asks any way to optimize NPC meshes, animated meshes, because they have a bunch in their game. And it's big performance hit.
Yeah, that's a great question. And I know that more animated mesh optimizations are coming. So animated meshes are pretty recent addition to core, and improvements and optimization for those will come to the editor over time. But at the moment, you kind of have to limit it. They're very expensive. They're high poly count, high triangle count, and they have the cost of the animation, and the skinned mesh has its own CPU costs on the clients. So you just kind of have to.
Yep. And you can do tests too, where you to get a feel for how expensive they are, because they are they do cost a fair bit as they are right now. So you just want to be a little bit careful with how many you put into your game. But you can just add a lot into an empty scene, like I was showing earlier, and just be like, hey, I've got a bunch of skeletons dancing around. How many skeletons until things start to get bad? And you'll get a feel for like how costly they actually are. It's really good. There's not a way to quantify that information and be really accurate, but most people that have a lot of experience will be able to, they kind of have a sixth sense for what the approximate cost is, right? Like they know something's heavy, something's medium heavy, something's really light, and using that to guide your decisions when you're adding things to your level is really, really helpful. One thing to show here is, so when you're looking at your networked object count, so you can see it's 160 right now, but this grenade does like an AoE check for things that I'm hitting. So as I throw it, you can see the number of networked objects is increasing. So your limit is not just the number that are in the scene statically, right? Like the choppers are networked. I think the doors are networked in this level, but like obviously the gun and the gameplay parts are, but also the actions that all of the players that are in the game are taking can increase your networked object count. So when you have a lot of players in your game and they're all doing things that drive up the networked object count, it can hit a really high level really quickly. So keeping in mind how that's why you want this number. These are like the most precious commodities in your game. So you want to use them really sparingly and as efficiently as possible. So this is this new.
Yeah, the recommended limit is 400 networked objects, but you can exceed that and it'll still work. But you should try to stay below that.
So K-pop Sim has a good question that I think dovetails into something that you were going to speak about anyways, Ryan. Are there any plans for different levels of detail for our kit passed models?
Got him. Yes, absolutely. So there's a feature coming fairly soon, which we're going to do another long talk on. That is really exciting. And it's been kind of mentioned before, but it's the feature name and development is called mesh merging, and it basically lets you create a model which is going to be a Manticore optimized version that gets sent once when you are going gets sent once to the server and constructs a single collidable mesh for that object. And so I can kind of show what it would look like.
But also single rendering mesh as well.
Exactly. So
it only has to do one check for batching and for calling. So it's a CPU optimization. Pretty big. It should be pretty huge.
Yep. So as using Sniper Alley is probably it's a very good example. It's a feature that's going to help different games to different degrees. But if you run, let's see here, it's actually game settings, enable the profiler, and so let's look at this because this is a feature that everyone is going to want to use because their games are going to run so much better with it implemented. So if I hop out here.
So this is where we need Jordan Leaks to come out and tease what we're doing with Sniper Alley because a bunch of changes are coming.
Yeah, so here you can see, and this is when you're actually looking at the rendering. This is a pretty common case that you'll see where it's like everything's like kind of close, right? Like the game thread is pretty simple for this game. The logic isn't really doing a ton. There's some UI pieces, but it's fairly pared down. The render thread is a little bit higher than you'd want, and it's synced up to the GPU time, so these two are close. When this is the case, it basically means you've got a lot of objects in your scene, and not surprisingly, there's all of these different buildings here, right? And so what this feature is going to do is you can put these different buildings, in some cases, into different chunks, but it basically lets you put them into a new folder type. It's a model, and then they sort of become one mesh when you play the game. And so it's going to be dramatically more optimized. And those all these like little pieces, all these like chairs and like wood panels and pillars and everything is going to get sent once to the server, and then it's basically culled out. So your number of draw calls is going to go way down, and it's going to be easier for the computer to set up everything in the render thread. So so I did some tests with this new feature that's coming soon. And if I remember correctly, the render thread went from something like 25 or 26 seconds down to like 14 seconds. So it was a test I was doing. It's a really sizable improvement because it doesn't have to create draw calls for all of these different buildings and different pieces. So we're gonna do a more detailed stream on that in the future, but that's gonna open the door to having many more detailed, complicated objects in your scenes. So.
Now, speaking on this subject, so a related note that I wanted to bring up is about breaking your game into multiple games, and that's something that is now possible with the shared key persistence feature. That's a lot. That went live yesterday, right? Or Tuesday?
Yep.
Yeah. So with shared key persistence, you can create, a massive world with hundreds, millions of objects, but you partition your world into scenes, into sectors. Each one is a separate game project, and you connect them together with portals and transfer players between them, and you can share the player progress data with the shared key persistence, so that when you have your gear or your coins or whatever that you've accumulated in one section of the game, you can go to the other one and take with you that progress. So that's what Boss Fight is doing. This is Boss Fight, right?
Yep.
So that's another strategy. If you have a very big game idea, very big game, you want to break that into a few pieces, have a central place, then a couple of destinations, something you can do.
Yep. Yeah, you can see it here. These rowboats take you out of this particular world and send you back into Corehaven. And so what's really cool about this is if you count objects here, right? Like you've got 15,000 objects. It could be probably, you could pile a little bit more on, but you have a lot of these nice buildings. You have all the environmental effects, all of the game logic and everything. But if you tried to fit another High Rock into this High Rock world, you'd have a lot of trouble. So this opens up the option for having multiple interconnected levels, and it just expands what you can do exponentially.
And you guys also did different difficulty levels too, right?
Yep, and that's just going to be changing more stats than sending it to a different level exactly. But yeah, so that's going to be a really, really helpful trick for making very big worlds that are interconnected.
It's live right now, y'all.
It is live. It's really fun. I want to play.
Right? I know.
Yeah. I don't know if it's
the fourth
it will be
unfeatured. You actually go to Corehaven first, and then you go down to the dock and talk to the guy standing next to the boat. And boom.
Yep.
So what about static context? Because that's been used quite a bit recently. That's talked about quite a bit recently, but it's probably one of those things that's really confusing.
Right. So objects have two states. They're either networked or not networked. A static client context is a very specific use case that might not be totally clear to everyone. So a static client context is when you have a complicated piece of geo that you want to spawn in or move at runtime. So a really good example of this would be so say you have an obstacle course, and there's a fist. You've made it out of a bunch of different primitive pieces, and you're actually rotating that fist around. It's something that you have to dodge as you're running through the obstacle course.
Daddy-o.
I'm not sure if I have an example up for this. Yeah, I'm thinking of Daddy-o's game. You want that whole fist to be in a static client context, because you only need to send that static geometry once, and you're not doing anything with it. It's just you send that from the server to the client, and then you're good. So that's really the main case. It's when there's a big piece of geometry that you don't have as your default static geometry in the level.
It's like a lot of small pieces inside the static piece, and then you manipulate the static piece, and the small pieces move.
Yeah, exactly.
Yeah, one way that I think about it, I think about everything that's under the static context as locally within that group. They don't change, they're immutable, but you can still move and rotate the group above. So that's an important optimization, and they retain collision, and scripts that are inside the static context are going to run on both the server and the client. That's also a very unique distinction, because scripts generally either run in the server or they run in the client, depending on how you set them up. But in the static context, they will run on both, but they won't communicate with each other directly, right? So
Chaz says, Gabe, when are you putting in level streaming into Core?
level streaming, I don't know. That's a great question. I don't really know. I think it's gonna take a little bit. There's a lot to figure out.
I'm digging that hand, Ryan.
Yeah, it's beautiful. Yeah, there's just as a really quick overview for the context. This is default context. This capsule here. This is the context that you would use the majority of the time. Anything that's not networked would be in default context. If you are doing anything that requires communication between the server and the client, you need to have something in a network context. So, for example, the bullets like we were showing earlier, or this trail.
Mm-hmm.
This is actually the non-optimized one, but I'll show the better bullet, right? So this needs to be networked because you have a player on their machine saying, "I'm going to fire this bullet, spawn this thing," right? And it can be in a client context because this is basically a wrapper that says you just want to only you only want to pull it in once. You only need to send one message. You would have a networked something that would be networked would be like a soccer ball in a game that everyone needs to be getting constant updates about that object. And then the static client context, this hand is sort of a good example. If this were attached to something that were rotating around and you had to dodge this hand that was trying to smack you, you would just have these capsule pieces. These are in the static context, and you're just sending this collision data once, essentially. Hopefully that's...
And
you
static
probably
is
want to
where
right-click the static context and enable networking on it, right?
Right.
And you can see that underneath they're not networked.
You would use the static context, the reason you didn't use it on the windmills to rotate the windmill is because you didn't need the collision, correct?
Correct. Yes. Thank you. I should have said that. Yeah. The important difference is that you get the collision in the static context. In this case, if there is this giant hand that's trying to smack you, it's important that you have that collision data, right? It might actually matter for your game that the grooves between the fingers are somehow relevant, or the exact length of the fingers, right? Really matters. So that's why we would want to be using this. Another case would be if you spawn in a gigantic castle into a game, you would want that to be in a static context, because that'd be a lot of different individual pieces, and you'd want that to come in as one thing and not have all 5,000 blocks be networked. So hopefully that's clear. Typically, anything that is that's ephemeral that you're spawning, you're going to want to have be in a client context. So typically sounds and VFX are almost always going to be in a client context in 99% of cases.
And for people, who for the static context is going over your head, don't worry about it, because that's an advanced feature that in my games I've rarely used it. I've made entire games without static context, so you don't really need to use it.
I've threatened to use it many times, but I've only used it once.
Yeah, it's very rare that you're going to be using this. Typically, server and static contexts are not going to be that common, and server contexts that's only going to live on the server, right? So players are not going to be interacting with this. They're not going to interacting with it. They're not going to have it on their machines at all. That's kind of the whole point of it.
So that would be something you do to securely process something that you didn't want the player to be going into the client and messing with.
Yeah, and there's exactly there's other applications that are useful too. Let me see if I have a farming game up so I can show one. To find it in the list here. Jeez. All these different projects.
Nia Alchemy is asking if players can cheat and jump to a location they didn't earn. you can protect against that in your game if you're concerned by writing to their player to their shared player progression. Like when they earn access to that place, you can write and secure it more. I don't know if how secure it actually is, the portal. I don't think it is at this time, but I'll make a note of that and I'll inquire about that. That's a really great question. It's a really really interesting possibility to consider. So thanks for asking that.
Punkarella said we did have to use a lot of static context for Trick or Treat Town, though I have no idea how any of it works. Boo Radley. Boo Radley is magic.
Yeah, when you do use them, it allows you to go bigger in your game if you want to go the extra mile.
So I'm going to show something here.
These are your farming hacks?
Yeah, so this is showing here. It's just the small dig sites, but I guess these are just a folder. And the location of the dig sites gets sent, it gets all registered on the server, and then it gets sent out to the client. But the actual, so you can see all of these many small dig sites that exist in the farming game for metal detecting.
Did you just level those up, or did you just make them stick up like that, or are they invisible?
I made a cube.
Oh, okay.
Yeah, they're not visible, but I just made these cubes and I updated the template.
Gotcha.
So we wouldn't want to have all of these as networked objects, but you want to spawn all the different locations where things could be spawning, right? Like where you can find stuff. So it's actually fun to run around and not know where stuff's going to be. And as you can see, there's so many. Like I would never mentally be able to track. Oh yeah, there's one that like next to this tree here. The whole idea behind the feature is that it would be fun to explore, and then you would sort of clear stuff out, and new different spawns would become available. So this is just an example of using just the data from the server to the client, and just bringing these without creating a lot of networked objects. And this is available for anyone to look at.
Very cool. Rolock says, define change in regards to static context. What can't I do in static? And this just recently changed too.
It's the same as if it were default. So it's like you brought in something into your game at runtime in a default context. And once it's there, you can't do anything with it.
You can delete it now, right?
Yeah, they have an option to delete.
Yes. You can delete it now. That's the one thing you can do. Yeah, so I can show that. Cool. I think we're almost out of time. Are there any other questions?
Yeah, were some really good questions.
Excellent questions. Do you guys get a lot out of this? I know I did. I was just as much a student of this.
Every time we have these sessions, I always learn a little bit, even though I've been working on this project since the beginning.
Right?
There's always something to learn. There's always a new detail that's coming along. Like I didn't know about the multiplayer options. Like I heard about it, but I hadn't even seen it yet.
Right. Well, I want to thank you and Ryan, because I know you guys are both busy, for doing this for the creators, because this is an important piece. Punkarella says it's very helpful. I really like to make things optimal when I can, and y'all do. And I want to thank Tasha for setting this up and hosting and not clowning on us too much.
Yeah, I just
the threat was there.
Is this like the Mulan army training?
Oh, yes.
Yeah.
Let's get down. Exactly.
To defeat the hunt.
To defeat the lag.
Yeah. Yeah. So hopefully, like by going through this, like you can have the tools to see, like just by logically testing, to see sort of how expensive different things are, and understand like sort of the different techniques that you would use. Sometimes it's a little bit tedious to go through, but like you can actually find the right way to build something by sort of bringing it into an empty scene and looking at it carefully. It's really great to do that early if you're going to have a particular prop that's going to be replicated a lot in your level.
Right.
So you kind of go into it with the optimal version, and then just understanding. I mean, something for me for sure that's been really helpful is like a question I ask that doesn't really have an answer is how much does this thing cost? Like how many points does it cost? And I have a budget, and it's like way too complicated to really clearly like distill that into some number. But you can get closer to an understanding of like, okay, an animated mesh is like 300 points and a cube is 1 point, and a VFX volume is 50 points depending on the size and the particle density. And like, none of that's really even true at all. But
and Lane Chan has like more than it. No, maybe Lane Chan had like a whole society going on in their game. So of animated meshes. So I was impressed that it didn't lag as much as it probably could have. So quick question. Oh, first of all, Tasha, Uku liked your version of the song better than mine.
Thank you.
And to defeat the lag. And then the other thing is, they are dead. The other thing is, how did we do this before these tools were available?
We just made smaller games.
The answer to that's kind of funny. We sort of we had some engineer-only tools, but we kind of didn't. Right? Like a lot of it is there were a lot of unknowns with this, and so it was kind of a rough feel that you could get from just looking at the frame rate, but you couldn't get the level of granularity that you can get now. So. Now we have much more sophisticated tools to look at the specific costs that you're incurring. And everyone can use them, So like being able to go in and be like, oh, cool, I've got all this, 2 milliseconds of character animation time for those animated meshes, and what's expensive here? 21 milliseconds for the render thread. What's going on there?
If you had sounds playing here, like, how much more would that cost?
Not really much. Typically some things that you might think are expensive are reasonably cheap, like lighting and sounds, and sometimes post-process effects are not too bad. Things that can be surprisingly expensive are VFX with really high particle density and particle size, both together. Very big trigger volumes and particle volumes, especially if they're moving at runtime. If you're like moving a gigantic trigger at runtime, that's like mega expensive. That's going to crush your frame rate. Obviously, like animated meshes can be expensive, and then network objects are sort of the most perilous but the most valuable. So hopefully that's kind of like a super quick and very rough guide.
What's your silver?
One of the questions from earlier, and Curtis mentioned if the army was grunting here, this would definitely be a case where you would want to do a client-side script that just calls the play function on a clock. Because the animated meshes are client-side only, and it's a predictable pattern. And even if it wasn't repetitive like this, if there was some sort of pseudo-random but deterministic algorithm, then you should definitely be playing the VFX and the sound on client-side, because it's purely cinematic and environmental effect. You don't want to be spawning those over the network. There's just no gameplay relevance to doing that over the networks. Like one of the questions you can ask yourself is, do all the players who are watching this need to see the same thing happen, or is it okay if players don't see exactly the same thing? And if it's okay that players see slightly different things, then you can get away with not networking it. That's one of the questions you can ask yourself.
Yeah, that's no Gabe's smoke grenade, and
yeah, don't use my smoke grenade from community content.
that thing's like there goes your video card. All right, everybody. Thank you for showing up. We're going to continue to do these cool things. I'm super excited that Ryan has actually come and joined the CR team now, and so we're all. You're going to see a lot of us. Get used to it. Hopefully, we'll get Ryan's beautiful mug on the camera next time instead of just the screen. All right, and thanks again, Tasha, for hosting.
Oh yeah. No
Can I mention
problem.
one more point about performance? So it varies a lot by hardware, by computer, obviously. One thing that I noticed is that if you have an AMD card versus an NVIDIA card, you'll get a different sort of personality for these metrics. So if you're working on a team with another person, if it's like 2 people or a couple of people and you're trying to optimize together, always check which hardware your team has and make sure that you're not like going crazy like, oh, it looks this way to me and for you it looks another way. Maybe one of you has an AMD and the other has an NVIDIA. So that's something that I actually ran into on my team when making a game. So something to remember, that each hardware is different.
Alrighty.
Yep.
Man, that's
Ryan
crazy.
just melting his video card right now.
Yeah, don't start a fire. Don't start a real life fire.
It's gonna get too hot. Yeah, but this is a good example actually. Like this is just a fire volume, and I just put some crazy like stupid high settings on it, and then also it's like on top of these animated meshes. But it's not like, I mean, there's all these like Mulan trainees here, but this is one object. So with one object and really high settings, you can get insane like level GPU times. Very easily, right? Like I think I just put in like 35.
What is that? 1 frame per second?
So yeah, it's definitely like half a frame or something. Like yeah, it's pretty bad. So just it's definitely a learning process. But yeah, going through and experimenting a little bit will really help you out to learn like what things cost when you're designing levels and making decisions for your game. So yeah.
Awesome. All right. Tasha, next time you got to be on screen. So we can make sure you're not taking a nap.
What the heck, man? I'm just quietly working over here and learning through osmosis.
Right?
All right. Thanks, Ryan,
What's
Curtis,
next?
and Gabe for coming on. All right. Signing off. Thanks, folks,
Bye
for
now.
tuning in.
See y'all later.
So, yeah.